Hello students, welcome to the amazing platform of Physics Wallah. Welcome to the PW English channel, my dear students. So today we are on the lecture 2 of surface chemistry. I hope all of you are clear with the first part which we discussed in the lecture 1, where we discussed about what is the basic difference between adsorption and absorption. We had a complete discussion about adsorption. We also drew the Friendlich isotherm curves of adsorption as well. So we have studied everything about adsorption, and today we'll be starting a new topic, which is your colloids. Yes. So next part which we will be discussing is colloids. So let's start this amazing session, my dear students. I hope all of you have revised the last lecture and also read the NCERT as I asked, because now we will be solving a few questions based on the topics we discussed in the last class. Now let's start the amazing session, my dear students. What are we going to cover? We'll be covering colloids, types of colloids, and what is micelles. Okay, perfect. Let's start. The first question is, now these questions are based on the topics we have discussed in the last class. So I hope all of you have read the NCERT and you have revised all the topics. Okay. So my dear students, what the first question says, adsorption of gases on solid surface is an exothermic process. Is it adsorption a exothermic process? Let's try to understand. When we talk about exothermic, so for exothermic, we know that delta H is equal to negative, that is heat is released. Okay. So now my dear students, whenever new bonds are formed, energy is released. Whenever bonds are broken, you have to provide the energy. Now new bonds are formed, energy is always released, that is delta H is negative. And if we talk about the exothermic and if we talk about the adsorption process, yes, when the gaseous particles come and adsorb on the surface, we say that new interactions are formed. And yes ma'am, that is a exothermic process, because when new interactions are formed, energy is released, right? Yes. So yes, it's true, adsorption of gases on solid surface is the exothermic process, and because new interactions are developed. Okay, let's read the options. Free energy increases, entropy decreases, entropy increases, interaction developed between gas and solid particles. Yes, so option D is your correct answer. I hope you're clear with this. Now let's move forward to the next question. The next question says that the nature of bonding forces in adsorptions are. Now you have to tell what is the nature of bonding forces in adsorption. Obviously adsorption is happening, you have a adsorbent and adsorbate comes and gets adsorbed on the surface. Okay, so few interactions are formed. Now we basically classify adsorption into two major parts. One is your physisorption and the other is your chemisorption, right? Yes, in chemisorption, chemical bonds are formed, chemisorption. And if you talk about physisorption, then my dear students, weak van der Waals interactions are formed. So they have not specified which particular adsorption, so we'll have to consider both of them. So both types, van der Waals weak interactions as well as chemical bonds. Yes. So purely physical as such as van der Waals, purely chemical, both chemical and physical. Yes, so option C will be your correct answer. I hope you're clear with this. Perfect, my dear student. This is how you have to solve the questions. So easy, right? Yes. Let's move forward to the next question. Okay. Next question says that which one of the following is not applicable to chemisorption. Now we have to read the points and we have to tell which of the following is not applicable to chemisorption. Okay, let's see. First is heat of adsorption's negative. So you see, my dear students, be it chemisorption, be it physisorption, adsorption process, new interactions are formed, and every time, whether it is chemisorption or physisorption, interactions are formed. So ma'am, energy will be released. Delta H will always be negative. So heat of adsorption is always negative. So it is applicable to chemisorption. Okay. Second point is it is reversible. Is chemisorption reversible? No. Strong chemical bonds are formed. You cannot reverse the process. But in case of physisorption, weak van der Waals interactions are formed. So you can reverse the process. So this is not applicable to chemisorption, because chemisorption is irreversible, whereas physisorption is reversible. It takes place at high temperatures. Yes. Every particular reaction need a particular temperature, which is some high temperature. So yes, high temperatures are required for chemisorption. It forms Monomolecular layer. Yes, since there is strong bonding, chemical reactions have to occur, so it is only a monolayered, it is not multi-layered, whereas Physics option is multi-layered, right? Yes, so only one is not applicable, that is, it is reversible. Please note it down. I hope you've noted down. Next question. The next question is on your screen. Try to do this question on your own, my dear students. What does the question say? The question says that which one of the following characteristics is correct for physical adsorption? So now you have to tell about physical adsorption. It has weak van der Waals interaction, that we know, right? Yes, now let's read the points. First is it is very specific. Is the physics option very specific, my dear students? We can say that the gases which we say that it is okay, specific, fine, but not very specific. Only the gases which can be liquefied can be adsorbed. So we have to read the other points to get to the correct answer. Second says adsorption on solids is irreversible. What we have to tell? Which one of the following characteristics is correct? You have to tell only one which is correct. Okay. It says that adsorption on solids is irreversible. It is a physical adsorption, and physical adsorption have weak van der Waals interaction. So it is reversible. Okay, it is reversible because the force of interaction is very weak. So this is wrong, right? It is reversible. Adsorption decreases with decrease in temperature. No, actually adsorption decreases with increase in temperature. This was the plot. X upon m, extent of adsorption, time, and it always decreases with temperature, increase in temperature. So this statement is again wrong. Generally, both enthalpy and entropy of adsorption are negative. Is it true or not? Let's talk about this. Both enthalpy, see, enthalpy is delta H, and since new interactions are formed, so it is always negative. That is absolutely true. Okay. And entropy of adsorption. Let's talk about the entropy of adsorption, delta S. My dear students, it is also negative. This statement is absolutely correct. This statement is absolutely correct. Okay. Now we'll say, ma'am, this is also correct and this is also correct. Now, my dear students, let me just tell you here that this is a point. Generally, both enthalpy and entropy of adsorption are negative. This is absolutely correct. It is true. It is true for your chemisorption and physisorption as well. Okay. If we talk about it is very specific, my dear students, it is not very specific, but yes, it is specific because only the gases which can liquefy can be adsorbed. The other gases will not be adsorbed on the surface. So we'll say that here two options are correct, A as well as D. There should have been a little more clearance about the point so that we could have found one answer, but till now we can see that both of the options are correct. Okay, perfect. Please write it down. Let's move forward to the next question. Done. Okay, next question. The question is here. Which of the following statement is not correct? So you'll have to tell which of the following statements is not correct. Okay. It says that physical adsorption is due to van der Waals forces. Physical adsorption, yes, weak van der Waals forces. So this is correct. This statement is correct. Physical adsorption is irreversible. No, physical adsorption is reversible because it has weak van der Waals interaction. Chemisorption is irreversible. So this statement is wrong. Third, chemical adsorption increases with increase in temperature up to certain limit and then decreases. Yes, if you draw a plot of chemisorption, it would be like you have X upon M, extent of adsorption, then you have time. It will increase at a particular limit, it will then decrease, and this is how your plot for chemisorption looks like. So this statement is correct. Enthalpy of adsorption for a chemical adsorption is greater than that of a physical adsorption. And that is absolutely true because in chemical adsorptions, strong bonds are formed. The more the bond is strong, the more the energy will be released. Okay. Whereas in case of physical adsorption, very weak interactions are there. So very less amount of energy is released. So this statement is also correct. Okay. You have to tell which of the following statement is not correct. Only one, that is this. So option B will be your correct answer, right? Yes, perfect. Please write it down, then we'll move forward. Just a second, students, just a second, and then we'll move forward. Okay. I hope you've written it. Now let's move forward to the next question. The next question says that which of the following factors affect the adsorption of a gas on solid? Okay, now let's see which of the factors affect the adsorption of a gas on solid. The first is critical temperature. Yes, my dear students, critical temperature gives you the idea whether a gas is liquefied or not. Easily liquefied, then obviously it will be more strongly adsorbed. So yes, this actually affects the adsorption process. Temperature of a gas, yes, my dear students, the more the temperature, the lesser will be the adsorption. So yes, it also affects. If we talk about the pressure, pressure is directly proportional to the adsorption. The more the pressure, the more will be the adsorption. So yes, so answer would be all of these. That is option D. Option D will be your correct answer. I hope you're clear with this. Perfect, my dear students. Let's move forward to the next question. We have a lot of questions too. Question says that which of the following is used to adsorb water? Which of the following will be used to adsorb water? Okay, you have options. You have silica gel, you have calcium acetate, you have hair gel, you have anhydrous CaCl2. I told you that when you talk only and only about adsorption, my dear students, your silica gel will adsorb water, but your anhydrous CaCl2 will absorb as well as adsorb. Okay, this was something in our notes in the previous class. So option A will be your correct answer. Okay, I hope you're clear with this. Perfect, my dear students. Please write it down. Then we'll move forward. Let's move forward to the next question. The question says that absorption and adsorption are respectively. Absorption is a bulk phenomena because it is absorbed inside the body as well, and adsorption is a surface phenomena. So first is absorption, so it should be bulk phenomena, and then it is adsorption, so surface phenomena. Option D will be your B. Option B will be your correct answer. Okay, perfect. Let's move forward to the next question. Adsorption is multi-layer in case of when you have weak interactions, that is your physisorption or physical adsorption, right? Physisorption, physical adsorption, option A will be your correct answer. I hope you're clear with this. Let's move forward. Next question. Reversible adsorption is, which is a reversible adsorption? Obviously, where there will be weak interactions, weak van der Waals interactions, their adsorption can take place. Yes, ma'am. And that would be reversible as well. So we say that physical adsorption, option B will be your correct answer. Your chemical adsorption is irreversible process. Okay, perfect. Because strong chemical bonds are formed. Now let's talk about the next point. The next point is on your screen. Sorption is the phenomena where adsorption as well as absorption, both of them take place simultaneously. So where adsorption and absorption takes place simultaneously, option C will be your correct answer. Such easy questions are asked. Okay. Which of the following adsorption isotherms represent the adsorption of a gas by a solid involving multi-layers of layers. Okay, so we know that the adsorption would be something like this. Option A, it will increase at one particular point. It will be a constant value, which is your Freundlich adsorption isotherm. So option A will be your correct answer. Perfect. Yes, please write it down. Then we'll move forward. The heat evolved in chemisorption. Since in chemisorption strong chemical bonds are formed, so the heat evolved will be a large value from 80 to 240 kilojoule per mole. So option A will be your correct answer. Everything was in our previous notes, so you had to revise the all the notes. Only then you could have answered all these questions. Yes, perfect. Now let's start our today's session. So now, my dear students, what today we are going to talk about is colloids. So now, to understand colloids, we need to have a clear understanding of true solutions, colloids and suspensions. So now let's talk about the true solutions. Okay, let's take an example. Let's take an example of a solution. We have a solution. I have water and I have mixed sugar in it. Okay. Once I mix the sugar in it, can I see the particles of this sugar solution separately? No, I cannot see them separately from my naked eyes. Why? Because their size is too small for my human eye to see it directly. Yes, and that is the reason it is known as a true solution, where you cannot see the different particles with your eyes, right? Yes. Also, my dear students, it is a homogeneous solution. Homogeneous solution we have studied in solution chapter what is a homogeneous solution. It is a homogeneous solution, that is, it has homogeneous, the composition is fixed in all areas, it is not different. Okay, so it is a homogeneous solution and the particle size is less than 1 nanometer, and that is the reason not visible to human eye. So we'll say not visible to human eye. Okay, perfect. Now let's talk about let's say I have water and I have added sand to it. Okay, so now my dear students, when I have added water, I have mixed water and sand to it. Is it a homogeneous solution? Is the composition fixed everywhere? No ma'am, it is not fixed, and we can see different layers there. What is that? That is a heterogeneous mixture. And same way, my dear students, your suspension is a heterogeneous mixture. So your suspension is a heterogeneous mixture. Heterogeneous mixture or solution. Now when you talk about a heterogeneous solution, the solution in which you can see the particles with your human eye, that would be known as your suspension. Okay, so the particle size here, my dear students, is more than 100, is more than, I guess, 1000 nanometer. Yes, it is more than 1000 nanometers. Okay, yes, so this is what is known as your heterogeneous solution, and it is visible to human eye. We can see the sand and water differently, so it is visible to human eye. Right? Yes, perfect. So this is the difference between a true solution and suspension, and now we'll be talking about colloids. Colloids actually lie in between these two ranges. Okay, so please write it down and then I'll make you write about the colloids as well. Now, when we talk about colloids, my dear students, your colloids actually lie in between these two. Okay, the size range is, it is more than 1 nanometer, but it is less than 1000 nanometers. Okay, and it is not visible to human eye. It is not visible to human eye. And also, it is a heterogeneous mixture. It is a heterogeneous solution. Perfect. So I hope you're clear with this, that colloids are actually heterogeneous system in which one substance is dispersed in very fine particles, right? It will be a solution in which one substance will be divided, will be mixed in a very fine particle of the another substance. Okay, and now we have talked out completely about the ranges also. If you talk about a true solution, it is a homogeneous solution and it is not with the particle size is less than 1 nanometer, not visible to human eye. If we talk about suspension, it is a heterogeneous mixture, visible to human eye, and its size ranges more than 1000 nanometer. And if you talk about colloids, it is a heterogeneous solution, but the size ranges between 1 nanometer to 1000 nanometer, and it is not visible to the human eye. Okay, perfect. This was the major difference which we need to understand. Please write it down and then we'll move forward. I hope you've written it. Now let's move forward. Now, my dear students, we have quite a bit idea about what is colloids. Now we need to classify these colloids on the basis of different conditions. Okay, what are those conditions? We'll be understanding this. We'll classify colloids on the basis of their physical state, whether it is solid, liquid or gas. You have two different mediums in colloids. You have one dispersed phase and one dispersed medium. We'll discuss everything about it. We'll be discussing those on the basis of their physical state. Second is based on the interactions between the particles, and third is the based on dP and dm. Yes, so these are the few things which we will be discussing today. So please write it down and then we'll move forward. I hope you've written it. Now, the first is based on the physical state. See now, my dear students, you know that a solution is made with a solute and a solvent. Basically, you have something in which the other thing is dissolved. Okay, this is how we classify a solution. Okay, so now you know that matter can have majorly three states which we are discussing: solid, liquid and gas. Yes, ma'am. You have three states. Either your the container or the medium which you are taking in which the other substance will be mixed, that can have 3 different states, and the part which is getting mixed, that can be also of these 3 states. So 3 into 3, total 9 possible different types of colloids you can have, right? Yes, you can have majorly 9 different types of colloids, because 3 into 3 would give you total 9 different types of colloids, right? Yes. But if we see, we have 1, 2, 3, 4, 5, 6, 7 and 8. You have only 8 type of colloids. Where is the 9th type of colloid? So for this particular thing, you need to write a note here that gas in gas is a homogeneous true solution. It is a homogeneous true solution. So only and only one type, that is gas in gas, is considered always and forever as a homogeneous true solution. It can never be a colloid. Okay, rest all we'll be discussing today. So you have to understand this table. This is very important. Now the question arises that, ma'am, why are you not calling them as solute and solvent? Because they are considered as solute and solvent in true solutions. When you talk about colloids, my dear students, you have 2 different things. Now, what are those different things? We'll be understanding. You have, in colloids, you have dispersed phase, which is called as DP, and you have dispersed medium. Known as DM. Okay, so this is how we classify a colloid, that how a colloid is formed. We know that for a solution, homogeneous solution, you had solute and you had solvent, and you had solvent in larger amount. Right, we used to say the one with the more number of moles is considered as solvent, and solvent is the medium which provides a medium in which we actually dissolve the solute. Similarly, my dear students, colloids have a dispersed medium which will provide a medium for the dispersed phase to come and mix into it. So you can say dispersed phase is your solute and your dispersed medium is your solvent. Okay, so in this way you can understand how your colloids are made. Now these can be solid, liquid and gas. This can be solid, liquid and gas. So 3 into 3, total 9 different types of colloids must have been there, but only 8 types are there, because gas in gas is always a homogeneous solution. So it is always considered a true solution. If you want to write it, please write it down, then we'll move forward. I hope you've written it. Now, my dear students, let's move forward. Now, let's try to understand based on the different physical states of your dispersed phase and dispersed medium. See, the first thing that you always want to remember is that whenever your medium is gas, you only have 2 options where your medium will be gas. Here, your dispersed phase is solid, and here your dispersed phase is liquid. It is always known as aerosol. It is always and always known as aerosol. So just memorize it. Whenever your medium is gas, it will be aerosol. If gas in gas, then it's a true solution. Just leave it there. But if it is solid in gas or liquid in gas, it will be called as aerosol. And these are the examples which you need to memorize. Okay, perfect. Next, my dear students, solid and liquid, we have studied it over and over again. We consider it as a solution. In colloidal case, you say it is a sol. So just remember it. Solutions, pet name, sol. This is the colloid. Okay, I hope you've remembered this also. There is no issue. Now, if you have solid in solid, it will be a solid sol. Solid in solid, solid sol. So this is the solid sol. Okay. Next, whenever you talk about liquid in liquid, my dear students, imagine what milk. Our milkman, what does milkman do? He takes milk, he adds water to it, and he gives us, right? Yes. So what is milk? Milk is water in liquid, right? Water in milk, right? So liquid in liquid, that is an emulsion. So your milk is always an emulsion. That is liquid in liquid is always emulsion. Okay. If you have gas and solid, then it will be a solid sol. Okay. Yes. So my dear students, we have memorized all this. If you have liquid and solid, it will be a gel, and if you have gas and liquid, it will be a foam. You can remember that those foam, when you take a bath, the foam that is created, that is because you are using liquid, and the gas is getting trapped into the liquid and you get foam, right? Yes. So these are the few names which you need to memorize. Definitely a question will be asked from this table, and these are the examples which you need to memorize. Okay. This is a table from NCERT, and you need to have a thorough knowledge of this table, because definitely question will be asked from this particular part. Okay, so you need to write this down or either mark it in your NCERT so that you can memorize it. I hope you've written it. Now let's move forward. Okay. Now, next is the classification based on the interaction between your dispersed phase and dispersed medium. Okay. Now, either your dispersed phase and dispersed medium would like each other, or they might not like each other, right? Yes, these are the two possibilities which can take place. Either dispersed phase and dispersed medium have a good interaction, or they will be different, they will repel each other. Okay, these are the two cases, we'll discuss them. Whenever you see a word philic means something loving. Okay, so if your dispersed phase and dispersed medium have a strong interaction between them, those will be known as lyophilic. And if they have a very bad interaction between them, kind of repulsion is present there, then my dear students, they will be known as lyophobic, because this is something hating. So we can say that lyophilic are solvent loving. That is your dispersed medium loving, and these are your solvent hating. You can memorize it from this part. Okay, now let's try to understand this a bit more. Okay, these sols are prepared by simple mixing of DP and DM. Now if DP and DM are loving each other, this means that they will easily be dissolved. Okay, you have two friends who are very good friends. You can easily ask them to stay in a room, because they are friends, they'll definitely stay happily. Okay, they'll accept it readily. If you talk about two friends who don't like each other, if they don't like each other, and if you have only one room in which you have to ask both of them to stay, then you'll have to plead them, you'll have to give a little bit of, you know, emotional drama there, that we only have one room, please try to adjust. They'll say no, we don't want to stay together. This means that you'll have to use special methods to ask them to stay together, right? Yes, that is the case, prepared by some special methods. Okay, I hope you're clear with this. Now let's talk about the second point. Second is, my dear students, it is reversible. It is reversible means that, let's take the example of friends only. If you are two very good friends, you will talk to other people, but at the end of the day, you'll come together and you'll say, we are the best friends, we'll always talk to each other. So this is reversible. They went to someone else, they talked to someone else, but they came back and talked to their best friend as well. But it is the reversible. If you have two people who don't like each other, if they start talking with someone else, they'll never ever want to talk to each other again. They'll always find one way or the other to not talk to each other, right? Yes. So they are irreversible. They are stable due to solvation. Now let's try to understand how they are stable to solvation. Okay, now imagine, my dear students, you have a ion Na plus. Okay, you have added Na plus into water, and water is a good solvent. They both like each other, so it is a lyophilic condition. So my dear students, how they are stabilized is, you have water here. Water stabilizes your ion like this, and this is known as hydration, or you might call it as solvation. Okay, so this is what is known as solvation. Okay, when your solvent particles stabilize the ion inside it through this process, this is known as hydration or solvation. Okay, so they are stable due to the process of solvation, but since they don't like each other, they will be unstable. They just want a chance to just go and away from each other. Okay, so they'll be unstable. Okay, 3 points understood. Fourth point and fifth point are important. You need to memorize them, because viscosity and surface tension are terms of physics, and you'll understand more about this part in physics. Whenever you talk about viscosity is of dP is greater than dm. Your dispersed phase, the viscosity will be more than dm. That is your dispersed medium. Here, my dear students, viscosity is same, it is same as DM. So the viscosity of DP and DM is nearly same. You need to memorize it. Next is surface tension is lesser than DM. Okay, dispersed medium, comparatively to the dispersed medium, the surface tension is less. Here it is almost same. Okay, so this is something which you need to memorize. Okay, now let's take the examples, and this is an important point because most of the questions are asked from this 6th point, my dear students, that which of the solvents do we call as lyophilic, and which of the solutions do we call as lyophilic, and which of the colloidal solutions do we call as lyophobic. All the organic compounds like starch, cellulose, gelatin, gum, etc., all these are known as lyophilic salts. All the organic compounds are your lyophilic salts, right? If you talk about lyophobic, all the inorganic compounds like metals, metal sulfides, etc., they are your lyophobic salts. They are your lyophobic salts. All organic, lyophilic. All inorganic, lyophobic. Okay, you need to memorize this because definitely question will be asked from this point. Okay, please write it down and then we'll move forward. I hope you've written it. Now let's move forward. The next classification is based on the particle size of your DP and DM. That is your dispersed phase and dispersed medium. This is majorly classified in 3 different types. The first is your multimolecular. Now what happens here is, my dear students, on dissolutions of atoms, small molecules aggregate together to form species having size of colloidal range. Now you know that particle size could be less than 1 nanometer, it could be more than 1000 nanometer, or it could be in between, right? Colloidal range is 1 to 1000 nanometer. You have very small particles, let's say size is lesser than 1 nanometer. We cannot call it as colloidal solution, but you want to make it a colloidal solution. What will happen? These small particles will combine together, that is, they will aggregate together, and now the complete size would be between 1 nanometer and 1000 nanometer. So this is what is known as the first multimolecular colloid. What is multimolecular colloid? You didn't have the appropriate size range of the particles. The particles together came united together and formed a range and formed an aggregate which had the size range of colloidal solution, and that is the reason how it formed the colloid. Okay, so this is the first type. Okay, so we say gold, sulfur, etc., all these form your aggregates and form your and come to the colloidal range. Okay, now let's talk about the macromolecules. Now macromolecules are the molecules which individually have a very large size, more than 1000 nanometer. They want to come to the colloidal range. How will they come to colloidal range? They'll break themselves. And eventually they will form, and they will come to the range of the colloidal form, that is 1 nanometer to 1000 nanometer, and this is how they form a colloid. Okay, so let's see. Macromolecules like proteins, polymers on addition of a solution form a species having the size in the range of colloidal range. Now, which are the macromolecules? All the polymers are actually your macromolecules. See, starch, cellulose, proteins, enzymes, all these are macromolecules. All these are your polymers. Okay, yes. So I hope you're clear with this. Here, small particles aggregate together to the colloidal range. Here large particles break themselves. Here large particles break themselves into the colloidal range. Okay, so this is how a multimolecular and macromolecular can be classified into the colloidal range. Okay, perfect. Please write it down. I hope you've written it now. The next type of classification, not the next type of classification, the third form of this range is your micelles. Okay, now let's talk about the micelles. How micelles are formed? It is known as associated colloid. Now what happens is, my dear students, sometimes particles do combine together, but still they do not form colloidal range. But as you keep on increasing their concentration, a particular concentration is reached where they start behaving like a colloidal solution. This means that you have particles, you did aggregate them, you brought them together, but they are not behaving as a colloidal range at one particular temperature. That temperature is known as Kraft temperature. At one particular concentration, the concentration is known as the critical micelle concentration, they behave like a colloid solution. Okay, so this is the difference between multimolecular and associated colloids. That in multimolecular, you had small particles, they did aggregate together and they directly formed a colloidal solution. But in case of associated colloids, particles do come together, but they'll not start behaving as colloidal solution. At one particular concentration, they will behave as a colloidal solution. Let me give you an example. Imagine you took a soap, okay? You took a soap, you wanted to wash your hands. You took a very small amount of soap and tried to make foam out of it. But you will not be able to make foam out of it because appropriate amount of concentration is not reached. You will take a little bit more of the soap. When you have appropriate amount of soap, now when you will try to create the foam, your foam will be created. And this is the critical micelle concentration that you used, and at that one concentration the foam was created. So this is how you can, a little bit of understanding you can get about the associated colloids. Okay, now let's try to read it. Some substances at lower concentration behave as normal electrolyte. They'll behave as normal electrolyte, but exhibits colloidal behavior at a higher concentration. And this higher concentration is actually your critical micelle concentration. This higher concentration is known as critical micelle concentration. The aggregate thus formed is called the micelle, and at the critical micelle concentration, the aggregate formed is actually known as micelle. Okay. The micelles are formed above a particular temperature, and this particular temperature is known as the Kraft temperature. So you need a particular temperature and a particular concentration, which is the CMC, that is your critical micelle concentration. Okay, perfect. So this is how you form a associated colloid. Associated colloids behave as colloids at a particular concentration at a particular temperature. Okay, whereas the other two at one particular range will start behaving as colloids every time. So this is the difference between the associated colloid and the other types of colloids. Some substances, and the best example for this is the soap. This is the best example for soap. Okay, soap at one particular concentration it will behave normal electrolyte, but at a particular concentration it will start behaving as a colloid, and you can see the foam being created. Okay, perfect. So please write it down and then we'll move forward. I hope you've written it. Now let's move forward. Now, my dear students, let's try to understand a little bit more about this part. Okay, so let's talk about the mechanism of micelle formations, how your micelle is formed, or how your detergent works. Okay, so soap actually consists of, whenever you talk about a soap has some formula. I'll give you a formula. Let's take an example of a soap, C17H35COO negative Na positive. This is a type of soap which is known as sodium stearate. Now, when you see this soap, my dear students, you will see that you have a very large part of hydrophobic part here. And here is some ionic part. So in a soap, my dear students, you have a long form of carbon chain which is hydrophobic in nature, and then you have this COO negative Na positive part which is ionic in nature, that is, which is hydrophilic in nature. It should be hydrophilic. Now I have used two words. One is hydrophobic part and one is hydrophilic part. See, hydro stands for water and phobic stands for hating. So this is water hating. And it is hydro water. Philic means loving. So this is water loving. So in a soap, you have two different parts. One is your hydrophobic part, that is water hating part, and one is hydrophilic part, which is water loving part. Okay. So now what actually happens is, so I have written that soap has two different parts. Let me draw it like this, which you will understand a little bit more. Let's say this is the hydrophobic part, and let's say this is the hydrophilic part. Okay. So this is how a soap can be represented. Okay. This would be your hydrophobic, and this will be your hydrophilic. Okay. I hope you've got the idea about a soap. I hope you've got the idea about the soap. Yes? Perfect. Now I'll make you understand the cleansing action of soap. Okay. So now you have this type of soap particles all over the soap. Okay. So now let's say you have a cloth. Let's say you have a cloth like this. And let's say this is a dirt particle here. I'm just taking an example. So I'm taking a very small dust particle. Let's say, no. Let's say this is a dust particle. So now what happens is, you know that the soap is something like this. Right? So what happens is, you apply soap here. Okay. So now, my dear students, your soap at your critical micelle concentration, that is CMC, what will it do? You have this as hydrophobic part, this as hydrophilic part. So if I talk about this dirt, this will be a hydrophobic. So your soap actually forms parts like this. Okay. And the hydrophilic part is facing water, because water will not be present on the dust particle, but all around the dust particle water will be there. So the hydrophobic part concentrates on the dust, and your hydrophilic part concentrates on the water, and such this type of something is formed, and this is known as your micelle, and this micelle is formed at one particular concentration, which is known as your critical micelle concentration. And then when such micelles are formed, you rub it, and these just take the dust away. So this is how a soap helps in cleansing. And this is how a micelle is formed at a critical micelle concentration. Let's read it. Soap molecules form micelles in oil droplets. I have taken dust. Let's take oil droplet. Oil droplet itself will be hydrophobic, and the part outside it will be hydrophilic, in such a way that the hydrophobic part is present in the droplet. The hydrophobic part is present on the droplet, and the hydrophilic part away from the oil droplet. And then you rub it, and you get your answer, and you get your oil droplet out. This is hydrophobic, and this is hydrophilic. I hope you're clear with this. Perfect. Please write it down, draw it, try to understand it. And again, I'm saying, read the NCERT. If you'll read the NCERT, only then you will understand everything clearly. Okay, because there complete paragraph is written on the mechanism. I can only make you understand the mechanism here, but you'll have to read that part to have the clear picture. Okay, perfect. Please write it down and draw it. I hope you've written it. Now, my dear students, we have talked about how we can classify the colloids. Now we will be discussing how we can prepare the colloidal solution. There are n number of ways to form the colloidal solution. How we can form colloids, that is the next part. Okay, so fasten your seat belts, because now a new topic is getting started, that is methods of preparations. Okay, so what are the different methods? The first method that we will be understanding is your chemistry reactions. Yes, chemical method, my dear students. These are simple reactions. You just have to read the reactions, and only NCERT reactions are important, not anything else, because question will be asked only from that part. So let's try to understand it. The first reaction says that you have double displacement reaction. So that is, displacement will occur. Okay, you have arsenic here, you have oxygen here. Can I say that arsenic charge is +3 and oxygen is, see, this is +3, this is -2, this is again +1, and this is -2. Okay, if you are showing that their double displacement will occur, then arsenic plus will go with sulfur S. So let's say sulfur is here, this is -2, you have to cross multiply and you will get As2S3. So this is how you get the colloid As2S3. The rest part, oxygen and hydrogen, you have H +1 and oxygen -2, cross multiply, you get H2O. This is the next part you get. So double displacement is super easy. Double displacement is super easy. Just write the charges and then cross multiply in the opposite charges. Okay? Yes. So this is the first method how you can prepare your colloidal solution. This is your sol, that is, this is your colloid. Perfect. The next is oxidation. The next is oxidation, my dear students. See, you have H2S. The oxidation of H2S takes place, and so what will happen? You will have sulfur here and you will have H2O. So this is how your sol is created. Sulfur sol is created by this chemical method. Okay. The next is your, here my dear students, it is HCHO. It is a aldehydic group. Okay. So it is HCHO. So you have a oxidation reduction reaction here. See, your AuCl3 is actually getting reduced to, Au sol. So here, my dear students, your reduction is taking place. I hope you can see here it was in +3 oxidation state and here it is in 0 oxidation state. So reduction has taken place. And at the same time, your aldehyde has actually got oxidized to the acid, that is your HCOOH. So oxidation and reduction takes place simultaneously. So when your AuCl3 gets reduced to Au, your aldehyde gets oxidized to the acid HCOOH. Okay, so this is how your sol is created, that is your colloid is created. Next is you have FeCl3, you hydrolyze it, you get FeOH whole thrice, which is your sol, and you get HCl. So basic reactions which you have studied till now in inorganic chemistry, all of them can be used to prepare your sols. But in your syllabus, you only have to memorize the reactions which are written in NCERT, nothing more than that. I hope you're clear with this. Please write it down and then we'll move forward. Okay, perfect. Can I have some water and then we'll move forward? Okay, please write it down. Okay, I hope you have written till now and you have understood everything. You'll have to read NCERT. That is the first and last solution to excel in this particular topic. Okay, perfect. Next. First was chemical method. That was simple reactions which you need to memorize. I have told you how the reactions are taking place. If you have a clear understanding of oxidation reactions, reduction reactions, hydrolysis reaction, you'll definitely be able to do those reactions. The next method is a very interesting method, and that method is known as Bragg-Arg's method. So what actually happens in a Bragg-Arg method, I'll just make you understand, and then you'll have a few points here, you can read them. But before that, you have to understand what I want to tell you. In Bragg-Arg's method, my dear students, the test setup is something like this. Let's try to understand this. So what happens is that this gray part is your ice. This gray part is your ice that is very cold. Okay, so I hope you understand that. We take a water bath, and in that water bath we take a ice bath. We take ice in that water bath, so we call it as ice bath. Okay, so we call it as ice bath. Now we put another beaker in here. Okay, now I have added some dispersed medium. The dispersed medium is the medium which I want for my colloidal solution. So what we did, we took a ice bath. We took a lot of ice into it. We added a container in the ice, and then in the container we added a dispersed medium which I want for my colloidal solution. We have a dispersed medium. Now we want the dispersed phase. How will we get the dispersed phase? What actually happens is you take two metal electrodes here. You take two metal electrodes here. Whichever metal colloid you want, you take that electrodes here. You attach them to the battery positive and negative terminal. So you took a ice bath, you took a container and you took dispersed medium into it, whichever medium you wanted, and then you took two electrodes of the metal of which you want to prepare the colloidal solution. And you connected both the electrodes to the battery, positive and negative terminal. Now you will pass a very strong electric current through those electrodes. You have connected it to a battery, so you pass a very high amount of electric current through these electrodes. Now when you will pass electric current through this electrode, what will happen? Your metal will come out as in gaseous form. Because you have applied such high electric current, your metal comes out as gaseous form. So it comes out in a gaseous form. Now since your dispersed medium is placed in a very cold environment, that is in the ice bath, the moment this metal comes out as gas, it just condenses. It just condenses, and as it condenses, it forms a colloidal solution. It forms a colloidal solution. So your dispersed phase is of the metal of which you have taken the electrodes. You have dispersed medium, now you have the colloidal range of the dispersed phase, and your solution is ready, and your colloidal solution is ready. So how your colloidal solution is made? You have decided that what kind of dispersed medium you want, which metal as your dispersed phase you want. You take the ice bath, right? You put the container, you put the dispersed medium in it, okay? Now you will take the metal of which you want the electrode dispersed phase. You put it into the dispersed medium, you attach it to the very high electric battery. It will have, one will have positive charge, one will have negative charge. You pass a very high amount of electric current, and the moment you will pass the very high amount of electric current, the metal will come out in the gaseous form. And the moment it will come out in the gaseous form in the dispersed medium, because of this ice, it will get condensed. And the moment it get condensed, you will get your colloidal solution. Dispersed phase is the metal and the dispersing medium is the medium which you took, right? Yes. So this is how Bragg-Arcs method is used to prepare the colloidal solution. I hope you're clear with this. First draw this diagram. And then we'll write the lines which are written in the next slide. So I hope you've drawn the diagram. You have to pause the video and draw the diagram. Now let's see. It involves dispersion as well as condensation. Obviously, dispersion is taking place, at the same time condensation is taking place, and that is the reason your colloidal solution is formed. In this method, an electric spark is struck between the electrodes immersed in the dispersed medium. The intense heat produced vaporizes the metal. Whichever the heat is produced, that vaporizes the metal, which then condenses to form the particles of the colloidal size. And finally, you get your colloidal solution. I hope you're clear with this, how your Bragg-Arcs method works. Okay, perfect. Please write it down and then we'll move forward. I hope you've written it. Perfect. Now, my dear students, we have discussed two different methods for preparing the colloidal solution. Now we will be discussing about the third and the most important method for preparing colloidal solution, because most of the questions are asked from this particular topic. The next method for preparing colloidal solution is your peptization. What is peptization? First, let me make you understand. What happens is, my dear students, you have a large number of particles. You have particles in the higher range. They are not in the colloidal range. Now you want to convert them to the colloidal range. So to convert them into the colloidal range, let's say you have PPT, that is your precipitate. Your precipitate is actually in the range of, you can see the precipitate, so it is in the range of suspension. Okay, you can see that part. Okay, now you break it into the colloidal range. For this, what is used is known as your peptizing agent. That agent which helps in doing this, Converting a PPT into colloid is known as peptizing agent, and this whole process is known as peptization. So basically the major picture of peptization is you have a aggregate or a PPT which you convert into the colloidal solution by using some peptizing agent. Okay, perfect. I hope you're clear with this. The process of converting PPT into the colloidal solution in the presence of peptizing agent with the dispersing medium. Obviously you'll need a dispersing medium. Okay, during peptization the PPT absorbs. Now I'll make you understand that what actually happens. Okay, let's say you have a PPT. Let's say you have a PPT. You add a peptizing agent to it. This peptizing agent converts this PPT into the colloid solution. That is, it converts it into the colloid. Okay, this is the major thing that actually happens. So what actually happens here is you have a PPT now which will act as a peptizing agent. Which ion will help in converting the PPT into the colloidal range, that we'll study in the next slide. So you can read it. During peptization the PPT absorbs one of the ion. Now this PPT will absorb some ion. Which ion? From the peptizing agent you will absorb one ion. Which ion? I'll make you understand which ion it will absorb. Usually the common ion on its surface. This causes development of charge, either positive or negative. I hope you've not got any idea from this. I'll make you understand. You have a little bit of the idea. That PPT will be converted into colloid with the help of a peptizing agent. Perfect. This was something I wanted. First write it down and then I'll make you understand this as well. I hope you've written it. Now let's try to understand the process. Okay, so now let's take an example. You have not this. Yes, let's take this example. Let's say you have silver nitrate. So you have AgNO3. So this is, let's write you have AgNO3. You added this with Ki, which is in excess. So I hope all of you remember your inorganic a little bit. If you remember your inorganic, then you know that AgNO3 on reaction with Ki will give you AgI, which will be a PPT plus KNO3. Okay, so this is the PPT. So this is the PPT which we have to convert it into. This is the PPT which we have to convert into colloidal range. Okay, so this AgI is your PPT. Okay, now which will act as the peptizing agent? Now let's try to understand which will behave as a peptizing agent. If you see, Ki is in excess. It is in large amount. You can use it n number of times because it is in very large amount. Okay, so you have AgI PPT and you have Ki in excess. So Ki will act as a peptizing agent here. So this is your Ki. Ki is your peptizing agent. I told you that Ki will convert this AgI into the colloidal range. And how will it do? It will absorb a ion. It will absorb a ion. Now which ion will it absorb? Always remember, it absorbs the ion which is common. This means that if you see, you have Ag plus and you have I negative, you have K plus and I negative. So I negative is the common ion here. So this absorbs the common ion from the peptizing agent and you get something like AgI. Then put one line and then you get I negative and then you get I negative. This is your colloid. This is your colloid. Actually what happens is you have AgI, right? Yes, you have AgI. What happens is it absorbs the common ion from the peptizing agent, I negative, I negative, I negative on its surface. So this is how I negative will be adsorbed on the surface of this and you get a charged colloid This is your colloid now. Okay, and this layer my dear students is known as fixed layer. This is known as fixed layer. Okay, so the layer which is formed by the common ion adsorption is known as the fixed layer, and this is how you get a charged colloid, and this colloid is negatively charged because the common ion was negative. So this is how you show the colloidal solution. Now what will happen of K plus? K plus will feel lonely and it will go there. Now my dear students, what happens is K plus forms another layer over this. Since it is negatively charged and K plus is positively charged, so it forms a layer above it in this way. But since it is a second layer, it is a mobile layer. So I'll say that K plus is a mobile layer. So it is a mobile layer. And how can you show this mobile layer here? You can just draw a line like, this, and you can write K plus. So this is how you get a colloidal solution. So what happens is you will make PPT. You will see which of the following compounds is in excess. You will use that as your peptizing agent. The common ion will be adsorbed and it will form the fixed layer. You will get the charge of your colloid, and the other ion will just form the second layer, which will be your mobile layer. Okay, yes. First write it down and then we'll do the same process for this part. Okay. I hope you've written it. Now let's see. You have excess of Ag and silver nitrate. So you have AgNO3 in excess. This time I have AgNO3 in excess and I react it with Ki. So what will I get? I will get Agi as PPT. I know this, and I'll get KNO3. Okay. So now this time my PPT is again KAGI. So I'll write AGI, which is my PPT. Now what will be my peptizing agent? This time, my dear students, AgNO3 is your in excess. So you will use that as your peptizing agent. So this time AgNO3 will be used as my peptizing agent. Now since it is my peptizing agent, which ion will be adsorbed? Just tell me. The ion which is common. Which ion is common here, my dear students? Ag plus 1, minus 1, this is plus 1 and this is minus 1. So ma'am, Ag plus is common. So we'll say that the fixed layer will be of Ag plus. So if you want to draw here, so you will have Agi here. And then around this Agi, you will get Ag plus. This time your colloid will be positively charged. This time your colloid will be positively charged. Right? Yes. And this will be your fixed layer. Let's talk about the mobile layer. The mobile layer will be of NO3 negative. So around this you will get NO3 negative. Okay, perfect. And this is your mobile layer. So this is how your colloid is formed. So if you want to write here, you will say that this is NO3 negative. Okay, perfect. So this is how peptization process takes place using a peptizing agent. And this is how layers are formed. This is how your colloids get charged. Okay, perfect. Please write it down and then we'll move forward. I hope you've written it. Now, my dear students, what happens is, let's write it here. You have a PPT here. Let's say we were talking about AGI and we knew that we have a positively charged ion here. And then we have a negatively charged ion above it. Since there is a, my dear students, difference of charge, they develop a potential difference between them, and that potential difference is known as zeta potential. So the combination of first and also, my dear students, the positive and the negative layer together, the first layer and the second layer together is known as your Helmholtz electrical double layer. The combination of these two layers together is known as Helmholtz double layer, and the potential difference between these two will be known as zeta potential. Okay. Yes, so these are the few points which you need to remember, that the combination of the first and the second layer is called the Helmholtz electrical double layer, since they are always opposite in charge, and also since they are opposite in charge, they will have some potential difference, and that potential difference will be known as zeta potential. So this is the zeta potential. We'll say that the potential difference between the first and second layer of Helmholtz electrical double layer is known as zeta potential. Okay, perfect. So please write it down. These are the few things that we need to remember. You can write it like this. Helmholtz electrical double layer. Okay, perfect. Please write it down and then we'll move forward. I hope you've written it. Now let's move forward. Please write it down. Now, today we'll only cover till here. We have discussed about what is colloids, how we can classify them, and what are the different methods of preparing colloids. From the next class, we'll start discussing about how to purify colloids, okay, and many more things. Now, whatever we have discussed till now, let's try and solve a few questions, okay. So let's try and solve a few questions. The first question says that crystalloid differ from colloids mainly in respect of. Now the first question that might arise in your mind is, what is crystalloid? My dear students, by crystalloid they just want to tell you they are talking about true solution, that is the size ranges less than 1 nanometer. So it says that crystalloids differ from colloids mainly in respect of particle size. So option C will be your correct answer. Easy? Yes. Please write it down and then we'll move forward. Next question, which one of the following is not used for preparing lyophilic salts? So my dear students, if we talk about lyophilic salts, we know that all the organic compounds are used to prepare the lyophilic salts and all the inorganic compounds are used to prepare the lyophobic salts. Let's see which of the following is a inorganic compound. Only metal sulfide is the inorganic compound, rest all are organic, so they can prepare lyophilic salts, but this will only prepare lyophobic salt. So option D will be your correct answer. Perfect. I hope you're clear with this. Now let's move forward to the next question. The next question says that which of the following is an example of associated colloid? We know that associated colloid is the colloid which is the compound which behaves as a colloid only at a particular temperature and only at a particular concentration, which is known as the critical Micel concentration, right? Yes. So ma'am, soap in water will be my correct answer. We just studied about this example, right? So option B will be your correct answer. Let's talk about the another question. Colloidal solutions are not classified on the basis of, let's see, molecular size. Yes, they are based on molecular size. We just discussed nature of particles. We did discuss this also. Surface tension value we haven't discussed, so this is your correct option. Interaction between dispersed phase and dispersed medium, lyophobic, lyophilic, we have discussed, so only option C is your correct answer. Let's talk about the another question. The another question is, which of the following is a lyophobic colloid? All the inorganic compounds form the lyophobic colloids and all the organic compounds form the lyophilic colloids. So we only want to see the lyophobic. So we need a inorganic compound. Gelatin is organic, starch is organic, gum arabic is organic, sulfur is inorganic. So option B will be your correct answer. I hope you're clear with this. Perfect. Let's move forward. Next, which of the following is not a gel? Which of the following is not a gel, my dear students? If I see here, I know one example for always, which is milk, and milk is always an emulsion. What is emulsion? Liquid in liquid. It is not a gel, it is emulsion. So option D will be your correct answer, else all are your gel. Okay. Perfect. So you need to remember that table. Questions will be asked from that table. Okay. Please write it down. Next question. Peptization involves. What does peptization mean? It means that you are breaking a PPT into the colloidal solution, right? Yes. So precipitation of colloidal particles? No, colloidal particles are not aggregating and forming a precipitate. A precipitate is getting broken into colloidal solution. Opposite of this, disintegration of colloidal aggregates. Yes, colloidal aggregates will give you PPT and you will disintegrate the PPT and you will get again the colloidal solution, right? Yes. Impact of molecules on dispersion medium, nothing like this. Purification we haven't discussed till now. So only option B is correct answer. Right? Perfect. Let's move forward to the next question. The next question says that the formation of colloid from suspension is. The formation of colloid from suspension is known as, suspension is your PPT and you are forming colloid from PPT, that is known as peptization. So peptization, option A will be your correct answer. Perfect? Yes, perfect. With this, let's end our session. We have discussed a lot about colloids today. We have discussed a lot of problems, questions based on the topics which we have discussed today. So I hope you understood every part. It is a theoretical chapter, my dear students. I will do whatever possible from my side, but most of the work you have to do because you have to read the NCERT for this particular part and you have to memorize all the tables in this part. I will make you understand each and every part, but you have to give a little bit more for this chapter because it is a theoretical chapter. So I hope you'll read the NCERT for all the topics which we have discussed today. We'll start from the next lecture, purification of colloids and everything. So till then, keep studying. We'll meet in the next session. Till then, bye-bye. Take care. All the very best.